Let me show you the worst case scenario. Let's execute this query in such a way the coordinated threads run on the same CPU core as the busy query running. Let's cut and paste this query into this window. Let's change the max degree of parallelism to 0. In the past we tried with 3 many times, and one time it completed fast. The other times it took 13 seconds to complete when max degree of parallelism was 0. Now let's execute this query. This query will take quite a long time to complete. The reason is, as a coordinator, whenever I want to fetch a bag of apples from any of the 4 people, Maria, Dave, Tom or Matt, I have to wait for my turn to use the car. Since the busy Sam is sharing the car with me, I have to wait every time I fetch a bag of apples. Since I have to merge all bags of apples, the execution time of this query will be the number of bags, number of pages multiplied by 4 milliseconds. Let's see if this query completed. Yes, this query completed took 84 seconds. Let's execute the query again with execution plan on. The query took more than a minute. We are executing again to see if the execution time is predictable. Let's look at how many rows were processed by this query. Right click, properties. There you see actual number of rows 83,521. Let's go to the calculator. Let's paste 83,521. Divide by 4 because we have 4 rows in a page. So approximately we have 20,000 pages. This is divided across 4 threads. So there could be few more number of pages. If we multiply it by 4, because to fetch every page I wait 4 milliseconds because I am sharing the CPU core where the busy query is running. There you see 83 seconds. This query should take around 83 seconds. Think about it. Dream about it. What will happen if, as a coordinator, I call the DBA Dale and tell him that he has me, the coordinator, running on the same CPU core as the CPU intensive query, and he should move me on to a different CPU core if he wants to deliver my results in a CEO report or a billing job on time. DBA Dale will be very happy for not missing out on his bonus. Let me bring you out of the dream. Let's return to the real world. This is what we do at SQLWorkshops.com. We help you develop deep technical SQL Server skills so you can establish level 400 communication with SQL Server without increasing your TCO, total cost of ownership. We found out we processed around 20,000 pages. If you go to sleep task, you will see 41,000 waits. Half of the waits was experienced by the coordinator and 1/4 by every thread that was processing the results. Since the coordinator processed half the amount of pages every time, the coordinator waited for 4 milliseconds, and that's the reason the execution time is very high. This performance issue will not affect all parallel queries. If your parallel query does not sort, there is no merging of sorted results, no bag-by-bag handling, the query will not suffer performance issue even when a CPU-intensive query runs on the same CPU core. Let me show you an example. Let's execute this query, which does not do an order by. Executes in parallel, exactly same query, except we select order status equal to max order status. The reason I removed this select clause is because the query then doesn't run in parallel. So by having a max, we make this query run in parallel. So without order by, Let's execute this query. There you will see the query always completes fast. Let's look at the execution plan. The query does run in parallel. And there you see the query always executes fast even if one of the CPU core is used at 100%. Let's move on to the disk I/O optimization. Before that, I want to share a discussion that I had with Mr. JLR. Mr. JLR at times says, money makes the world go round. I asked him if he can give us a practical example. This is what Mr. JLR said. Take a customer who is on Oracle, who is struggling to pay bonuses for his team because Oracle TCO, total cost of ownership, is very, very high. A salesman walks inside the shop and shows charts and PDF files with TCO savings customer can achieve with SQL Server. Customer is initially hesitant. The salesman says Microsoft platform is about total cost of ownership reduction, and the customer is finally convinced. Customer calls for a team meeting and announces they are moving to SQL Server. There will be reduction of TCO. And they can expect better bonuses this year, and we will buy a new coffee machine, the state-of-the-art authentic Italian coffee machine. Fast forward 2 months. There comes another salesman, a new salesman from a third-party company. He says to the customer they need to buy their third-party backup software. The customer says that the previous salesman said SQL Server has inbuilt tools that can perform backup. The new salesman says their third-party backup tool can better compress the backup. The new salesman says their third-party tool can monitor performance. The customer says the previous salesman said there is this activity monitor, profiler, database engine tuning advisor, and things. The new salesman says they can keep a history of performance baselines. The customer says, wasn't management data warehouse supposed to do that? Fast forward 2 months. The customer calls for a team meeting, points to the shelf where the third-party software and hardware manuals for backup, monitoring tools, and SSDs, solid-state disks are lined up. He says, there goes our total cost of ownership. Well, no Italian coffee machine. Money makes the world go round. Let's move on to the disk I/O optimization. Let's drop the stored procedure and let's create it. This stored procedure joins table 71 with a table temp. Let's execute the stored procedure first with parameter 25. Let's clear the cache with dbcc drop clean buffers, which is documented in Books Online, and let's select data from some irrelevant tables that are not related to our query. This is to fill up the cache so SQL Server can do 8 kilobyte IOs. If not, if you just clear the cache and don't fill the cache up, it will do 64 kilobyte IOs. Let's now execute this query. The first store procedure with parameter 1000. We will clear the wait stats like we did before, and right after we will look at the amount of page IO latch waits. While this query is executing, we will also collect performance monitor counters. I have include actual execution plan enabled. Let's execute this query and let's collect the performance counters. Let's freeze it. Let's analyze the counter. There you see the queue length is nearly 0.5 on disk N and 0.5 on disk M, together around 1. The disk seconds per read is 8 and 8 milliseconds. Disk read bytes, that's the throughput, is around 500 kilobytes per second, and again 500 kilobytes per second. And disk reads, the amount of reads per second, is around 58 and 60. The query took 17 seconds to complete, and it waited primarily for page IO latch. Let's take this number, the total wait time, and let's divide by waiting task count, 2046. There you see the average page IO latch wait time, 8.5. If you go back to the performance, counters, there you will see average disk seconds per read is nearly the same. This query waited for disk IOs to complete. Let's take a look at the execution plan. Right click, Properties. There you see physical operation nested loops. There is no tag which says unordered prefetch. It's neither true nor false. The whole tag is missing. And you see the estimated number of rows is 24.999. Let's execute another stored procedure. Let's drop it and create it. The content is the same. Join table 71 with table 10. Let's execute the stored procedure first with parameter 26. Let's drop clean buffers and fill up the cache just like we did before. And we will execute the stored procedure with the same parameter 1000 like we executed before, 1000. Again, we reset the wait stats and collect the page IO latch wait time. While this query is executing, we will enable actual execution plan, and also we will monitor the performance counters. Let's freeze it. Let's analyze the counters. There you see average disk read queue length is around 5 on disk N and around 5 on disk M, together between 9 and 10. Average disk seconds per read is around 50 on disk N and around 50 on disk M. Disk read bytes per second, the throughput, is around 800 kilobyte and 750 kilobyte on drive M. And the amount of reads is 94 and 91. Let's look at the execution time. The query completed again at 11 seconds. Let's take this wait time and let's divide by the waiting task count, that is 221. There you see it's 51. In our case, this average page IO latch wait time, 51, is again similar to our average disk seconds per read, which is 50. Let's look at the execution plan. Right click, Properties on the nested loop join. There you see the estimated number of rows is about 25. And below the physical operation nested loops, you see with unordered prefetch equal to true. This was missing with our previous stored procedure. When prefetch is disabled, SQL Server will issue one IO at a time as the nested loop join proceeds. When prefetch is enabled, SQL Server will issue IOs ahead of time, so the nested loop join need not wait for every lookup. I was investigating a performance issue at a customer, an OLTP implementation. There some queries were slow, always sitting on page IO latch waits. The disks were pretty idle. They had a high-end SAN, but hardly used. The disks were idle. They were doing joins, simple joins. Think about orders to order details join. I don't remember the exact table names. Some orders add more than 25 details record, some less, some a lot, like 200 or more records. If someone executes this stored procedure looking for order details less than 25, then the optimizer will disable prefetch for the stored procedure and cache the plan. Later on, if someone executes the stored procedure looking for 200 order details, they will have to do one IO at a time. At this customer, the IOs were fast, took around 10 milliseconds. Doing 200 IOs serially will take 200 times 10 milliseconds, that is 2 seconds. This is too long. Even though this customer had many spindles on their SAN, SQL Server did one IO at a time because the stored procedure was called first time to do less than 25 lookups, disabling prefetch and caching the plan. Think about it. If you have 400 lookups to do, that will be 400 times 10 milliseconds, 4 seconds. How many of you have SLAs, service level agreement, that says you have to provide 2 seconds response time? Let me show you an example. Let's drop and create the stored procedure PF3. The stored procedure is the same like we had before. Let's execute the stored procedure first time with parameter 25. Let's drop clean buffers and fill up the cache. And then we will execute the stored procedure with parameter 100. We will clear up the wait stats and we will look for page IO latch waits. This query is executing without prefetch because first time we executed the query with parameter 25. The stored procedure says less than 25, less than or equal to 25. SQL Server estimates 24.99 lookups. There you see the wait time is 2 seconds. And the waiting task count is 212. Let's go to the calculator. Let's say 2094 divide by 212. There you see around 9.8 milliseconds per IO. The query completed in 2 seconds. Let's drop and create the stored procedure again. Let's execute first time the stored procedure with 26 as the initial parameter. Let's drop clear the cache and let's execute our stored procedure with parameter 100. This time, since we executed with 26 as the first set of parameters, SQL Server will enable prefetch. You see, this query completes in 1 second, no more 2 seconds. And if you take this one and you look at the average time, 26, this is again 45, similar to what we saw before. This query is 2 times faster because I have 2 disks. If you have 10 disks, this query will be nearly 10 times faster. When you get these example scripts, experiment with it over your SAN with parameter value 200 or 400, you will see significant difference. I would like to take a short time and introduce you to the SQL Bits conference, SQLBits.com. The conference occurs 2 times a year in UK, United Kingdom. Even if you are not located in UK, you can benefit from this conference. All the sessions are recorded and made available for anyone to view. For example, I delivered a session, let's make SQL fly. Let's click on it. There is the abstract about this session. And if you want to view it, you can view it locally, or you can right click and save it in your desktop and watch it later. I would recommend you take some time to look at these sessions, great sessions from well-known speakers. What I like about this conference is every time they arrange one, they send an email to every member if they are interested in delivering a session at this conference. Once the session submitting deadline is over, all the members have an opportunity to vote to choose which session they want to see. There is no session selection committee or any other committee filtering out certain sessions. Democracy at its best. Additionally, the session recordings are totally free. Speakers are given free hotel accommodation, reducing all of our expense. Let me show you a different example. Let's drop and create the stored procedure PF4. Let's set the memory. So far, I had my memory set at 512 megabyte. Let's set it back to 8192. Let's drop clean buffers. We will not initialize with irrelevant data. We will just drop clean buffers. This means the query will do 64 kilobyte IOs initially until the cache is full. In the previous case, we had Average disk bytes per read was 8192. Let's clear the cache and let's execute with 25 in the beginning. And let's clear the cache again and let's execute our query with 1000 as the parameter. Let's monitor the data. Let's pause it and let's look at it. Average disk bytes per read, as I told you, is 64 kilobyte because we did not fill it with irrelevant data. Because for me, filling up 8 gigabyte with irrelevant data is going to be a lot of work. So we will skip that part. Average disk queue length is again less than 0.5. In this case, slightly above 0.5. Together, it is 1. And disk seconds per read is around 10 milliseconds per read, and the query completed in 20 seconds. I have 2 disks. What we are going to do now, create the store procedure. This time we are going to, the reason I create the store procedure is to create a new execution plan. We can either create the store procedure or execute SP, recompile, or we can use DBCC free proc cache and give the handle. I just use the drop because for our demonstration this serves the purpose. But if you are in a production server, if you want to clear the cache, you should use DBCC free proc cache with the handle like we discussed before. Just want to explain you the reason why I drop and avoid doing this DBCC free proc cache, because I have to get the plan handle and we will save some time. Let's create the store procedure again. First time, let's execute with parameter 26. Let's drop clean buffers and let's execute this query with parameter 1000. Let's look at the performance monitor counters. Let's freeze it. Let's look at the average disk bytes per read. Again 64 kilobytes because we did not fill it up with some irrelevant data. Average disk read queue length is no more 5, it's like 69. Since we have a lot of memory, SQL Server figured out it can issue more IOs. What will happen? Because it is issuing 69 IOs parallelly on this disk and 36 IOs on this disk, you will see the average disk seconds per read will be very high. It's no more 10 milliseconds, no more 50 milliseconds. It's 715 milliseconds. On the other hand, here it's 397 milliseconds. The reason for this high average disk seconds per read is we got too many IOs in the queue, but we got only one spindle underneath. It can do one IO at a time. Rest of them will wait in the queue, increasing the average disk seconds per read, the disk latency. But let's look at how long our query took to complete. It completed in 10 seconds. The previous query took 20 seconds. This query completed in 10 seconds. Scales very well, exactly 2 times faster because I have 2 disks. Mr. JLR says, if you are using a third-party tool, the colors will not be green anymore because average disk seconds per read is very high. Mr. JLR says any reasonable DBA will become uncomfortable looking at these numbers, but for us, the query completes fast, our CEO reports and billing job completes fast, and that's what we care about. Let me tell you, this is the best time to call the Steve. Remember the SAN administrator Steve, and tell him that we are not happy with the SAN throughput. You can hint him that maybe he can add more spindles to our loans, to our volumes as IOs are waiting. We at SQLWorkshops.com help you connect, communicate with the rest of the operations team in an efficient manner, avoiding flyby miscommunications. In this case, you can tell the SAN administrator Steve exactly how many spindles to add based on how fast you want the query to complete. We will also talk about how to force a prefetch. Before that, I want to share a personal experience with you. When I moved from Microsoft USA to Microsoft Austria, there were many surprises. It was a big move, international move. Of course, there were surprises, but there was this pleasant surprise. Human Resources Department, the HR told me I can pick a car from this list, and they gave me a list. You know, most consultants working for these companies get a company car in Europe. I, who used to drive affordable cars in the US, was excited. I looked into the list. There was this Audi, the BMW, and my eyes won't go down the list. It was stuck in the BMW. I was wondering, where in the world I'm going to drive a BMW? Well, I pointed at a BMW in the showroom, and it was in my parking lot. In Europe, in most cities, stores are closed on Sunday. You have to shop on Saturday. If not, you will starve over the weekend. One day, I wanted to go for shopping on a Saturday, and the car wouldn't start. I have had this problem in the past. Pumped more gas, and the gas flooded the engine or something. And you have to wait for the gas to clear up. For those people not living in the USA, petrol is the gas I am referring to. I didn't know how long this will take in a BMW. So I called their 24-hour premier support. I explained them the issue, and I asked them how long this will take to clear up on a BMW, as the shops will start closing soon. The support person told me that this does not happen with a BMW, and he will be there in half an hour with a replacement car, a car that is one level below my car level, so people don't abuse the replacement car. I told him that is fine. I don't plan to show off my car during my trip, so any car that can serve my shopping will be okay. Of course, when he starts the car starts. Like always, when the support is there, the problem will not reproduce. I asked him, what should I do if this happens again? He said he can enable monitoring software, and next time if this happens, they can trace the reason. Interesting. He said once they identify the issue, they can disable the monitoring. I drove this car up to 220 kilometers per hour, smooth ride. It is about 135 miles per hour. Let me tell you, if my car goes 220 kilometers per hour, I will not monitor anything. If it does not go over 200 kilometers per hour, I will be concerned. I will monitor. Ultimate goal being to fix the problem. To keep a history of baseline numbers and performance issues, I will use the management data warehouse, the MDW. Again, ultimate goal being to fix the performance problems. Monitoring alone is not useful. You got to fix the performance problems. Average time someone stays in the DBA job is like 6 years. There are exceptions. I know there are exceptions, but people eventually move up, move on. Let's not forget, these DBAs have executed DBCC CheckDB week after week for quite a long time. But think about it. In these 6 years, you want to be remembered in the history books as someone who fixed the performance problems, or someone who monitored these performance problems, someone who left these performance problems for the next generation to fix them. One way to force a prefetch is to use the optimize for hint in our store procedure to tell the optimizer that we are going to look for a lot more rows than 25. Let's drop this store procedure. Let's include option optimize for. In this case, we will just say 26. Let's drop clean buffers, and let's execute the query first time with 25. Let's look at the execution plan. Right click, properties. There you see with unordered prefetch equal to true. So even though we executed the query first time with parameter 25, SQL optimized it based on parameter value 26, so prefetch is enabled. So if you drop clean buffers and if you execute this query and you look at the performance monitor counters, there you will see the average disk queue length is high, even though this query was called first time with parameter 25. It is not necessary to say 26 to enable prefetch. You can also say 100 or 1000 based on average lookups, and if the numbers are higher, SQL can make further optimization. We have not got time to cover all these optimization techniques now. When the disk seconds per read, the disk latency or page IO latch wait time is very high, we will not simply suggest buying faster hardware or more disks. We will take a step back and see what is the requirement. Is the customer happy with the current performance of this report or billing job? If yes, there is no need to buy faster disk or more disk. 10 spindles might be enough for this report to complete on time. We will not push the customer to blindly follow best practice guidelines. When someone says the signal wait time is high, you need to buy faster processor or spread the load across multiple servers, we at SQLWorkshops.com will take a step back and look at the bigger picture. The CPU utilization was only 25%. There is no need to buy faster processor or spread the load across multiple servers. We will provide solution that addresses the issue without increasing your TCO, total cost of ownership. I know many of you are wondering what should be this average disk seconds per read value. When we added 10, the query ran 20 seconds. When we added 50, the query ran in 10 seconds. In our case, our disks take around 10 milliseconds for one random I/O. So when you have one I/O outstanding across the disk completes the I/O in 10 milliseconds. You can also have two I/Os outstanding on one in each disk. The I/Os will complete again in 10 milliseconds. But when you add more and more I/Os, 10 I/Os or 100 I/Os, the disks can still supply only one I/O in 10 milliseconds. The rest of them will wait in the operating system queue, increasing your average disk seconds per read. Let's look at the white paper from Microsoft, Troubleshooting Performance Problems in SQL Server 2005. That's also a white paper for 2008. Both of them point at the same numbers. Average disk seconds per read, 10 milliseconds, very good. Greater than 50 milliseconds, serious I/O bottleneck. These recommendations are very good. They apply if you have one I/O outstanding on each disk or spindle. In our case, with the first query, when you had one I/O outstanding over two disks, our disks completed the I/O in 10 milliseconds. That's a good thing. But with the second query, we did not have just two I/Os outstanding. We had 5 I/Os outstanding on each disk. So the disk queue length was high. The disk seconds per read added up because the I/Os were waiting in the queue and not being serviced. So when you look at these numbers, you have to be careful. You just shouldn't look at them literally. You should look at that relative to average disk queue length and the amount of spindles you have underneath. Prefetch is not all free. It has some locking overhead. We cannot cover everything here as we have limited time. Mr. JLR says he is surprised how SQL Server developers write code. When they type select statement, no lock hint comes automatically like second nature. If you got no lock hint, of course you don't need to worry about locking due to prefetch in your select statement. Mr. JLR mentioned why not freeze the plan. Execute the store procedure once with 26 as the parameter and freeze the plan. I asked Mr. JLR, what? Freeze what? He started looking at me as if I don't know what I am talking about. Mr. JLR asked me, you claim to be an expert? You don't know what is plan freezing? I said, yes, I don't know what is plan freezing. So we went on arguing about plan freezing, and we finally agreed. If we can freeze a plan with prefetch, then I will buy lunch for Mr. JLR. If not, Mr. JLR has to buy lunch for me. So we decided to search the books online. Plan freezing, search. There was this hit in feature supported by the editions of SQL Server 2008. There it was. Plan freezing for plan guides, Enterprise Edition and Standard Edition. Beyond that, we couldn't find anything about plan freezing. Then Mr. JLR told me, improved plan guide is plan freezing, slightly improved. So you can use the stored procedure sp create plan guide from handle to quickly create plan guides. Freeze the plan. He was still referring to freezing the plan. Let me tell you a story, a freezing story. I'm a bit shy about sharing it in a webcast, but it's okay if that story can buy me a free lunch. When I was a kid, we used to play games with friends. One of the games was freeze. I also played many other creative games, so don't underestimate my gaming experience. Anyway, let's carry on. In this game freeze, we keep moving around and suddenly someone says freeze. We all others have to freeze. The person who says freeze did not have a pistol or anything, maximum water pistol, so it was pretty much non-violent. When you hear freeze, you have to freeze, motionless. You cannot even move your fingers. If someone moves, even if it was just their pinky finger, it is no freeze. They lose. Mr. JLR and I agreed. If we can freeze the plan with prefetch, then I lose. This is what we did. Before the experiment, no third-party software will put a hand out and rewrite these queries. For example, force a prefetch to make the query faster. You have to do this yourself, and this is the kind of skills we transfer at SQLWorkshops.com. We have developers and DBAs who attended the workshop tell us the workshop has changed their career for good. Look at our workshop feedbacks at SQLWorkshops.com/feedbacks. Here is a recent feedback from a participant who attended our workshop from Credit Suisse, Switzerland last year. Thank you for these very useful webcasts you provide. Thank you also for the terrific performance and tuning course in Zurich last year. I have already made good use of the knowledge gained on the first day of the course and am much more confident in resolving performance related. The link. He means the link to our webcast 2 we sent to him. The link has already been distributed to my entire team and other SQL related professionals. This is what we did. We cleared the procedure cache. We did not supply a plan handle or SQL handle. By end of the webcast, we were a bit lazy, but if you are doing it in your production server, take time to find the plan handle or SQL handle of that stored procedure or statement and clear only the execution plan of that query or that stored procedure. Do not create the entire plan cache in a production server. Then we executed the stored procedure first with parameter 26. We made sure that the execution plan had prefetch enabled. Yes, prefetch is enabled with unordered prefetch true. Then we dropped clean buffers and we executed the stored procedure with parameter 1000. When prefetch is enabled and both of my disks are being used, this query will complete in 10 seconds. The query did complete in 10 seconds. And then we investigated if there are already plan guides in my database. There are no plan guides, so there is no need to drop them. Then we wanted to create the plan guide with this sp create plan guide from handle. We had to find the plan handle. So we executed this query in a loop. While this query was executing in a loop, we executed this plan handle selection from dm exec request for our session ID 62. There we found the plan handle. We took the plan handle, we stopped this query, and then we supplied this plan handle to this sp create plan guide from handle, and we gave a plan guide name. We created this plan guide. We checked if this plan guide is there. Yes. And then we cleared the cache again. So this plan is no more in the cache. Then we executed the stored procedure with parameter 25. Then we drop clean buffers like we did before, drop clean buffers, and then we executed the stored procedure with 1000 as the parameter. The query should complete in 10 seconds if prefetch is enabled. If not, the query will take 20 seconds to complete. The query is taking more than 10 seconds to complete. The query took 20 seconds to complete. Mr. JLR said we should double check if the plan guide is really used. So we went to the execution plan, right click, properties, and there we found our plan guide was in fact used. Plan guide has limitations. It cannot freeze everything. In this case, it cannot freeze prefetch. In the previous case, hash join and sort examples, you cannot freeze estimated number of rows to allocate more memory. You have to use optimize for int. Estimation is still based on first set of execution parameters or optimize for int values. When you look at it, every tool has limitations. Profiler, database engine tuning advisor, weight stats, extended events, activity monitor, third-party tools are no exception. The goal is to understand these limitations and work around them. Let me ask you a question. Have you seen a blog come alive, great technical article, week after week, month after month? You were excited, visited every week and learned a lot of new things. And suddenly one day, there were no more updates for weeks and months. You are wondering why the person doesn't blog anymore. Did he or she change the job? Let me tell you, it could be anything. Maybe his or her manager had other priorities. Maybe they didn't know people like you were interested in their work. There could be many more factors, but you do play a role in it. I request a help from you. Bringing these webcasts required a lot of work for us at SQLWorkshops.com. It was not just me who decided. My manager had to approve. Let me tell you, she wants to measure the visibility we as a consulting and training organization get out of these webcasts. What I ask you is to take a short time. I know your time is very valuable. This is our request. We ask you to take a short time to send the link to this webcast to your friends and local user community. Please don't take these webcasts for granted because it is free. It was a lot of work for us. We are not asking for your money. We want you to take just a few minutes of your time and send this webcast link to few of your friends. I wanted to cover many other real-world performance tuning topics. For example, a scenario where a query can be tuned to execute 8 times faster. This query has no disk I/O bottleneck, no memory bottleneck, has all the indexes, but slow using CPU at 100%. Kind of day-to-day query that you might execute on a front desk application, but we are limited by time. We cannot cover everything in webcasts. If you are interested, you can participate in our 3-day level 400 SQL Server performance monitoring and tuning hands-on workshop. We are delivering this workshop in Europe. If you want an on-site workshop, we can offer up to 50% discount. We provide on-site and off-site performance tuning consulting. Ask us for details. Like in the previous webcast, please send me an email. Join our mailing list if you want the example scripts. Be specific which example scripts you want. If you notice other instructors and speakers simply copy these ideas and concepts without giving credit to SQLWorkshops.com by mentioning SQLWorkshops.com website link in their material and speeches, tell them people at SQLWorkshops.com will not be motivated to deliver future webcasts if they are not credited for their ideas and concepts, and this will be a loss for the entire community. We at SQLWorkshops.com appreciate your help. Let me tell you one last thing. Say yes and say no. Say yes to TCO reduction, total cost of ownership reduction, and say no to anything that increases TCO, third-party software, hardware, services, and trainings. Ask yourself, why do I need this SSD, solid-state disk? Can I use the available memory efficiently? Ask yourself, why do I need this third-party performance monitoring software? Can I use the SQL Server native tools like SQL Profiler, Retrace, Windows Performance Monitor, Improved Activity Monitor, Database Engine Tuning Advisor, the Management Data Warehouse, the MDW, SQL Server Extended Events? If not, what are the limitations of these native tools? Ask yourself, why do I need this training or conference? Is it because it is being offered year after year, or is there some new content that can reduce my TCO, total cost of ownership? Ask yourself every time you spend your money. Ladies and gentlemen, on behalf of SQLWorkshops.com, I would like to thank you for viewing this webcast number 3. It was my pleasure sharing real-world performance tuning experience with you. Please send us your feedback. Once again, time to say goodbye.